Overheating. Have you ever left your smartphone in the hot summer sun and suddenly seen a warning message on the screen stating that the device needs to cool down before you can use it again? That is the device's internal safety mechanism protecting itself from overheating. Overheating is the absolute number one enemy of electronic components. It is the equivalent of running a car engine without any coolant or oil. If the temperature gets too high, the internal parts will quite literally begin to melt, permanently destroying the device. When you are preparing for your CompTIA A+ Core 1 exam, you will need to know how to accurately troubleshoot motherboards, random access memory, central processing units, and power issues. One of the most critical and common symptoms you will encounter and need to resolve in this area is overheating. To achieve that perfect score of 900, you must deeply understand the entire cooling ecosystem inside a computer. The central processing unit is the brain of the computer, and as it processes billions of instructions every second, it generates a massive amount of thermal energy. To manage and remove this dangerous heat, we use a combination of specific cooling methods, namely fans, a heatsink, thermal paste or thermal pads, and sometimes advanced liquid cooling systems. Let us break down the exact physical heat transfer process. The top surface of a processor and the bottom surface of a metal heatsink might look perfectly flat and smooth to the naked human eye. However, at a microscopic level, both surfaces are covered in tiny peaks and valleys. If you simply place the bare metal heatsink directly onto the bare processor, those microscopic gaps trap ambient air, and still air is a terrible conductor of heat. That is exactly why we must apply thermal paste or thermal pads. This specialized conductive material perfectly fills in all the microscopic air gaps, creating a seamless and highly efficient bridge for the thermal energy to travel away from the processor chip and into the metal heatsink. Once the heat moves into the heatsink, it travels rapidly up into dozens of very thin metal fins. This specific design creates a massive amount of surface area. The system then relies heavily on case fans to blow relatively cooler room air continuously across those hot metal fins, physically pushing the heat away from the processor and exhausting it out the back or top of the computer case. If any single link in this thermal chain breaks down, the entire system will suffer from overheating. In addition to standard air cooling, high-performance gaming or workstation systems might utilize liquid cooling. A liquid cooling loop uses a mechanical pump to circulate a thermally conductive fluid over a block attached to the processor. The heated fluid then travels through sealed tubes to a large radiator where fans blow the heat away. While liquid coolers are incredibly efficient, they introduce new troubleshooting challenges, such as a dead water pump or a slow fluid leak. Overheating is not just limited to large desktop computers. For your certification exam, you must also be ready to troubleshoot common mobile device issues. Overheating is a highly testable and common symptom in modern smartphones and tablet computers. Because these mobile devices are incredibly thin and do not have internal spinning fans, they rely entirely on passive cooling, which means they dissipate their internal heat directly through the exterior glass and metal chassis. If a user runs highly demanding applications like three-dimensional games or navigation software, while the device is actively charging and sitting inside a thick, insulating protective rubber case, that trapped heat has absolutely nowhere to go. This severe mobile device overheating can quickly lead to unresponsive digitizer issues, sluggish system performance, or the most dangerous physical symptom of all, a chemically swollen lithium-ion battery that threatens to crack the screen or catch fire. In a professional troubleshooting scenario, if you encounter a desktop system that repeatedly shuts down randomly under a heavy workload, you must first enter the basic input-output system or the unified extensible firmware interface to check the hardware monitor screen. You will look at the exact real-time processor temperature and verify that the cooling fans are actually spinning at the correct revolutions per minute. If the fans are functioning properly and the computer case has good, unobstructed airflow, you will need to power down the system, carefully unclip the heatsink, Thoroughly clean off the old, degraded thermal paste using isopropyl alcohol, and apply a fresh, pea-sized drop of new thermal paste before securely remounting the cooler. By mastering this exact chain of thermal transfer and understanding how to rigorously test each physical link, you will confidently breeze through any exam questions regarding temperature management. T.